Sorry, Daniel, your mic is a bit low.
Can you hear me better now?
Yes, but it's like it's not very clear.
Hello? Can you hear me?
Yes, now better.
Yes? Okay. I'll try to speak a bit louder, and in case you have any problems here with my voice or whatever, let me know, please. Okay, so let me present the job for next session, which will be next Friday, 19th of June. Remember that we have two more sessions, one next Friday, and the last one will be on June 26th. And then you'll have to send the report by 12th of July, which, as I said, is a flexible deadline, let's say it that way, in the sense that if you need more time, we can extend it maybe 1 more week or so. But let's keep that deadline for now. Try to send the report by then, and in case you need a bit more time, please let me know. Obviously, as always, I'm available every day in case you need to have a tutorship, to make questions by mail. Some of you have already made some questions, and we've had some tutorship, so no problem at all with that. Just we have to find a day and an hour which is good for both, but no problem at all. Okay. Let's see the work to do next week before Friday 19th. In this case, we're still analyzing the VIR EH1 core. It's like the second part of module 3. But now we're going from the simulators to the board, to the real hardware. And we start by, well, you should start by watching another video. Again, it was recorded in Spanish, but it's translated to English using AI. So use the version that you prefer. And it talks about three main things. First, about how to use performance counters available in the EH1 processor. It describes how we can configure and access those performance counters and get measurements of things such as number of cycles, number of instructions. Those are most basic, but also other things such as catch misses, branch prediction, misses and hits, and so forth. There are, I think, around 50 different events that we can measure using 4 performance counters available in the core. So the first part of the video describes how to use the performance counters, and also there's a guided example in section 3 here that explains you or gives you the steps to use them using a new project that you can download called Hardware Counters, which includes, which is already prepared for using those counters in an example program. Okay, so watch the video, the first part of the video, and do this example. The video also talks in the final part about how to run the CoreMark benchmark. It's a part about benchmarking. CoreMark, probably you all are familiar with it. It's a typical benchmark used in embedded systems, and it's adapted to RVFPGA in order to be able to use it in our platform. So again, the video explains how to do that, and you will have in the exercises, there will be a guided example of how to download a project prepared and how to use it in RVFPGA. Finally, although it's in the middle of the video, there's an extended part about how to extend the EH1 processor with new instructions and how to use them in a real program. In the previous module, you already extended the SOC. I don't know if you've already gone through that or you've completed that exercise. Probably you're working on it, or I know that some of you have already been working on it because we've had tutorship about that. You extended the SOC by extending the functionality of the 7-segment displays controller. That was in the previous module. We can do that because we have the sources for the SOC. Similarly, we can extend the core itself, the EH1 processor. As you know, RISC-V has base ISA, the base instructions, but it also has different extensions that we can include or not in our design. For example, the EH1 processor comes with the compress extension and the multiply and divide integer extension. Those instructions are present in the baseline core, and we can use them in our programs. Okay, you can use an integer multiplication, for example, in your program because the EH1 supports those instructions. However, the EH1 processor does not have a floating point unit. It cannot execute floating point instructions because it doesn't come with that extension. So the video shows how to extend the core with some with a subset of the instructions included in that extension, in the floating point extension. In particular, add a floating point addition, multiplication, and division. So the video gives some explanations about that, and later you will be able to do an exercise using those extended instructions in the core. Note that it's an optional exercise. I will talk more next day about this 4 exercises that you have to complete next day. But it's an optional, but I think interesting exercise to do because it allows you to understand how we can extend the core and use it in particular applications that make use of those extensions. So at least before next day, please view the video in order to understand what we're doing for extending it. So this is the job to do before next day. Summarizing, well, I didn't say anything about this first part. It recommends you to review, as we did in other modules, to review memory systems in a basic book, the Harris and Harris book that we've mentioned many other times, in case you need it, in case you don't remember how the caches, the cache hierarchy is designed, handled, the different policies, scratch path, for example. Those basic things should be reviewed in case you don't remember some of them. Anyway, probably most of you will not need to do this. Then the second is to watch this video, which includes 3 parts. And finally, you should analyze the hardware counters example in order to understand how we can use the hardware counters in our platform. For that, the first exercise, which is mandatory, will ask you to use the hardware counters in this program, which in fact is exactly the same program you've been working on today with the pipeline simulator. So the idea is that you measure performance using the hardware counters and compare its behavior with the performance measured in the simulator, which should be the same. It's not exactly the same because there are some differences in the way we're measuring in the simulator and on the board, but it should be almost the same. Okay, then there's another mandatory exercise about benchmarking using CoreMark and the memory system, configuring the memory system using or not the scratch pad available. And then there are two optional exercises, one about adding new instructions to the core, and another one, which is the one I already talked about last day, about other RISC-V cores, which is a complete section, you can access it here, that describes some of the RISC-V cores, and particularly it shows you how to use one of the most interesting ones nowadays, which is Wally Core, which for which you will need to buy the SD card, as I said last day. That's why it's an optional exercise. You can do it or not. It's not necessary for obtaining the best mark in the course, but it's recommended that if you can, you do it, because I think it's an interesting part. Okay, so well, this is the work to do. In case, as I was saying, in case you have any question during the week, please write me so that I can answer you by email, or we can do a tutorship. It's good for both. And please work on the tasks so that next session you can work on the exercises. Any question? Let me stop recording now. I'll share this with you as always.